How does gradient descent work in machine learning regression? Imagine trying to find the lowest point in a hilly landscape without a map. That's similar to how gradient descent helps machine learning models find the best fit for data. When we talk about regression algorithms, especially in supervised learning, the goal is to draw a line or curve that best matches the data points. But how do models figure out where that line should go? That's where gradient descent comes in. In simple terms, gradient descent is an algorithm that helps us minimize errors in our predictions. It starts with initial guesses for the model's parameters, which are usually random or set to 0. These parameters include weights, which determine how much each input feature influences the output, and bias, which shifts the entire prediction. The model then makes predictions based on these starting points. Next, we measure how far these predictions are from the actual data using a loss function. The most common one in regression is called mean squared error, which calculates the average of the squares of the differences between predicted and actual values. The larger the error, the worse the model is performing. Gradient descent then calculates the slope of this error with respect to each parameter. Think of it as figuring out which way the landscape slopes downhill. The algorithm then updates each parameter by moving a small step in the opposite direction of the slope, aiming to reduce the error. This step size is controlled by a value called the learning rate. If the learning rate is too big, the model might overshoot the lowest point. If it's too small, it might take too long to find the best fit. This process repeats many times. Each time, the model adjusts its parameters slightly, gradually moving toward the point where the error is minimized. When the changes in error become very small, the model has reached a point called convergence. At this stage, the model's parameters are optimized, and it can make accurate predictions on new data. There are different types of gradient descent. Batch gradient descent uses all data points at once to update the parameters. Stochastic gradient descent updates parameters after each individual data point, which can be faster but noisier. Mini-batch gradient descent strikes a balance by using small groups of data points for each update. In real-world applications, gradient descent is essential for training many machine learning models. Whether it's predicting house prices, stock trends, or even powering language models like ChatGPT, this method helps models learn from data efficiently. It's also important to understand from an ethical point of view because how models learn can influence their fairness and bias. If the training data contains biases, gradient descent will help the model learn those biases unless we take steps to prevent it. So, in essence, gradient descent is a step-by-step way for models to learn the best possible line or curve that fits the data, making predictions more accurate and reliable. It's a simple idea that drives complex systems to understand and interpret the world around us.